Introducing the new Uniset Universal Heatshrink Resin Combination Joint. We start off with the all-important cable preparation. Users should refer to the installation instruction sheet supplied with each kit. Mark out the armour and bedding dimension, and with a sharp knife remove the outer cable sheath. Mark out the bedding. Put a radial cut on the sheath, being careful not to cut into the cores. Remove any filler tapes using a side cutter and a sharp knife. Just to keep the cap of tapes in position, use some PVC tape at the end of the cores. Apply a length of the black mastic tape beneath the armours. This will act as a moisture block later on. Take the XLP earthing kit and with the constant force roll springs secure the earth braids to each core. Apply a length of grey mastic tape and bed the earth braids down onto this tape. Again, refer to the instruction and mark each core ready for the removal of the copper tape screen. A useful trick is to apply a roll spring at the end of this mark, and with a sharp knife circumferentially score the copper tape unravel it and tear it off carefully at this point. Repeat this on the remaining cores. Each core may have a phase identification tape. Remove this and then this can be tied around the cores to mark the phases. We now come to a very important step in the cable preparation on XLP cable. That's the removal of the semi-conductive screen. If done badly, there will be very high discharge levels at the screen cut and likely termination or joint failure. Use a suitable tool for this, or, as shown here, a round rat tail file. Filing against the edge of a roll spring will help to produce a level screen cut. You must file through the semiconductive layer all around the spring to reveal the primary insulation. This method may seem crude, but it does leave a very good tapered edge. and stress tape will fill any void when later applied. Use a semiconductive scoring tool and score the cores longitudinally as shown. Make sure the tool is set to the right depth so as not to score the primary insulation. Peel back the semiconductive layer, which should snap off at the screen cut. Repeat this on the remaining cores. According to the length of the connector, mark out the insulation and remove, ready to fit the connectors at a later stage. Remove the roll springs that help to achieve the screen cut, and with cable tissues wipe off any remaining residue from the primary insulation. Remove the remaining roll spring, and with the yellow stress tape marked for screen ends, apply the tape with stretch and extend onto the copper tapes and primary insulation by 10mm either way. This will melt and flow into the screen cut at a later stage. Now position the short lengths of coloured Heatshrink sleeve, which protects the tape at the end of the screen cut and also acts as a useful phase marker. Apply tape to the remaining screen cuts and position the other phase markers. With a suitable heat source, shrink these down, keeping the flame on the move all around the sleeves. The XLP cable is now complete, and now we move on to the cable preparation on the pilk side. Again, refer to the instruction sheets, measuring out the armours, the lead sheath and the inner bedding. In order to expose the lead sheath, we now need to remove the bitumastic layers from the cable. Using a gas torch to heat the cable will make this much easier. Use a wire brush to further clean the lead sheath. This will make a good earth connection point. Mark the lead sheath cut, and with a sharp knife make a circumferential cut on the lead. Score the lead longitudinally and peel off a strip of lead as shown. Apply a piece of screened copper bandage at the earth connection point. Fit a roll spring and connect the two earth straps back to the armours to be clamped down at a later stage. Apply a piece of black mastic tape around the remaining lead sheath. This will provide a further moisture block. On paper belted cables there is a carbon belt paper. This should be removed to a point 5mm from the lead sheath cut. Tie a twine binder at this point and unravel the carbon papers and carefully tear off against the binder. Apply a further binder 20mm from the end of the carbon papers and unravel the standard belt papers, again tearing carefully off at the binder. With a pair of sharp side cutters, remove the binders, spread the cores, and carefully remove any fillers. Be careful not to damage the cores. With a rag, carefully remove any excess grease from the cores. Take the clear oil barrier shrink tubes and position them over the cores. With a gas torch kit, shrink the bottom of the tubes as shown. And then rotate them in the direction of the paper so that they slide down towards the crutch. Once this is done, continue to heat the sleeves from the crutch end up to the top of the cores. Keep that flame on the move to remove any wrinkles from the sleeves. Now we turn the paper belted cable into a screen cable by means of fitting conductive heat-shrink sleeves. Position the conductive sleeves so that you achieve the dimension as specified in the instruction sheets from the end of the conductive sleeve to the end of the cores. Using a gas torch, shrink the sleeves into position. Take the grey mastic crutch wedge, insert it into the crutch of the cable and push down as far as possible. Stretch and apply the HV grey mastic tape around the lead cut and extend onto the bottom of the conductive tubes by approximately 25 millimeters. Tape back onto the lead sheath as shown, but don't cover the spring as we need this to make contact with the conductive breakout boot afterwards. Slide the 3-core conductive breakout over the cores and push well down into the crutch. Start by shrinking from the middle of the breakout . Shrinking the skirt down to the lead sheath . And then the legs to the cores. Because we've now created new screen points at the end of the conductive tubes, we now apply yellow stress tape to the end of each tube, overlapping 10 millimeters either way. Just as we did on the XLP cable, we fit the coloured shrink sleeves over the stress tape as before. mark out the cores, remove the insulation, ready for the connectors. Before fitting the mechanical connectors, position the connector insulation tubes down the longer cores. Here we're using mechanical shear bolt connectors that are tapered with conductors centralised. Crimp compression ferrules can also be used. User should refer to the instruction sheet supplied with the connectors. We have a core cross on this cable, so we're spacing out the cores to allow the connector insulation tubes to slide over the connectors. Before doing so, use cable cleaning tissues to degrease the connectors and primary insulation. Take the rolls of yellow stress mastic, fill up the gap between primary insulation and end of connector, and with stretch and half overlap, tape over the connector body, plug any holes that the bolts have left with small pieces of yellow stress tape, and with any spare tape, apply tape over these. Tape the remaining cores. Position the connector insulation tube centrally and with your heat source, shrink from the centre to one end at a time. Keep the flame moving all around the tubes to ensure an even wall thickness. The armour support ring is now fitted. Unless steel tape armour, then it's not required. Copper screening bandage should now be applied tightly around the centre of the joint and applied with 50% overlap down onto the copper tapes and then back again and bonded to the remaining cable side at the earth connection point. You can use a binder to temporarily hold the braids in position. Now, wrap the armour casing around the joint gap holding it together with PVC tape. And using the armour clamps, clamp down the fingers upon the support rings. Tap down any sharp points and apply black mastic tape over the clamp buckles and over the sharp finger points. Rough up the outer cable sheaths on both cable sides to provide a good adhesive key. With a hacksaw, cut down the tapered part of the shell in order to fit the cable diameter. Now offer the shell up to the cable and make a mark on the outer cable sheath at both ends. Make 2 further marks on the cage and apply the black mastic tape around these marks The application of this tape will allow the joint to be spaced apart from the shell so that the resin can fully encapsulate it. Apply a turn of grey mastic tape to the outer sheaths. And position the bottom part of the shell bedding up onto that mastic. In order to hold the shell together and contain the resin, use the little metal shell clips and knock into position. Once the clips have been fitted, apply PVC tape at both ends of the shell. Remove the 2-part polyurethane resin from the outer foil protective bag and mix according to the installation instructions supplied. Mix the resin thoroughly, cut a corner off the bag, and carefully pour into the shell. Once full, fit the shell cap. The joint is now complete. Allow the resin to fully cure before moving or backfilling the trench.